Hi everyone, Assalamualaikum. In this video, we are going to discuss integration by parts. We look back what inside this chapter, which is integration technique. We already discussed topic 1, which is integration of rational function using partial fraction, topic 2, integration of trigonometric function, and topic 3, which is integration by trigonometric substitution. So in this video, we are going to discuss integration by part, which is under topic 4, right? Learning outcome. At the end of this session, the student should be able to, number 1, recognize when to use integration by parts. Number 2, memorize the integration by parts formula. Integration of u dv equals to uv minus integration of v du. Number 3, use the integration by parts formula to solve integration problem. Number 4, memorize the ILATE acronym, which is I for inverse trigonometry, L for logarithm, A for algebra, T for trigonometry, and E for exponential functions. Number 5, recognize the potential function as u and dv. And number 6, recognize special case that allow the use of tabular integrals. Introduction. Let's say we have integration of x, e to the power of x squared dx versus integration of x squared, e to the power of x dx. It looks similar, but actually it's different, right? Right, let's say integration of x, e to the power of x squared dx. Let's say we use u substitution, u equals to x squared. Okay, we choose u equals to x squared. And when we use u substitution, we will have derivative part and integration part. Under derivative part, we need to differentiate. So when we differentiate u with respect to x, so we have du over dx equals to, we differentiate x squared, so we get 2x. And after that, we write dx as a subject, so we have dx equals to du over 2x. We just cross multiply, alright? And after that, we substitute back into the given question. Okay, so now we have integration of x e to the power of u du over 2x. Okay, from u equals to x squared here, we replace x squared equals to u. Okay, and from dx equals to du over 2x, we replace dx equals to du over 2x here. Okay, and after that, we can simplify x here and x in denominator. And at the same time, we can move constant over to outside integration sign. Okay, and after we move constant denominator to outside integration sign, so we have constant half integration of eu du. No more variable x because we simplify variable x from here, right? And then from integration of eu du, we can refer from integration of ex dx. The answer equals to e to the power of x plus c. So if we integrate e to the power of u du, the answer equals to e to the power of u plus c. So from here, after we integrate, we still have half in front here. And then after we integrate eu du, no more integration symbol. And when we integrate eu du, the answer equals to eu plus c, right? We use this formula, right? And after that, we need to replace u in terms of variable x. So from here, our u equals to x squared. So the final answer equals to half e to the power of x squared plus c. Okay? Right. Let's say integration of x squared ex dx. Let's say we still want to use u substitution, u equals to x squared, and then we need to find du over dx, which is equals to 2x, and we write dx as a subject equals to du over 2x. And after that, we substitute back into the given question. We replace u equals to x squared. Okay, x squared from here we replace by u, and then we still have e to the power of x, and we replace dx equals to du over 2x. Okay, and from here we can't simplify variable x. Okay, so means that we use the wrong method, right? The correct method to integrate this question is we need to use integration by parts. Okay, so integration of x e to the power of x squared dx, we can integrate using u substitution, and integration of x squared e to the power of x dx, we can integrate using integration by parts, right? Now we look at integration by parts using Euler rule. What is Euler? Euler is, from this table, I stand for inverse trigonometric function, L stand for logarithmic function, A stand for algebraic function, T stand for trigonometric function, and E stand for exponential function. Alright, these are some examples for this function, right? And R here means non-repeatable, and R means repeatable. Non-repeatable functions are inverse trigo function, logarithmic function, and algebraic function. It is called non-repeatable function because when we differentiate or integrate this function, we will never get the same function. While repeatable functions are trigonometric function and exponential function. It is called repeatable functions because when we differentiate the exponential function, it becomes the exponential function. And when we integrate the exponential function, it becomes the exponential function as well. The same goes for trigonometric functions, right? Right, so inverse trigo function, logarithmic function, and algebraic function are non-repeatable function. And trigonometric function and exponential function are repeatable function. Alright? Using Euler rule, whichever function comes first in the table list, it should be u, which is easy to differentiate. Note that dx always include in dv. There are two methods to solve integration by parts. Number one, using formula, which is integration of u dv equals to uv minus integration of v du, right? And method 2, before that, this method can use for all types of question involving integration by parts, okay? And method 2, to solve integration by part, we can use tabular integral, okay? Tabular integral, we only can use this method if the function has repeatable function. In other words, we only can use tabular integral if the given question has trigonometric function or exponential function or both of these functions, right? Coming up next, Formula integration of u dv equals to uv minus integration of vu. This is integration by parts formula. And then we will discuss example 1, which is integration of ln x dx. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.